Today we're going to go over evaluating algebraic expressions with integers. This is an algebraic expression because there are variables, numbers, and operations. So what we're going to do is look at how do we evaluate this expression if we know the value of each variable. So the first thing we're going to do is rewrite the problem but replace all the variables with their numbers. So off to the right is where I'm going to show all my work, and you want to make your work look like a Christmas tree. So you'll see what I mean by the end of this video. Some of you in class last week, we spent time looking at the Christmas tree, so you'll know what I'm talking about. So I'm going to start by doing negative, and then b is equal to -5. Okay, plus 9 times -2 minus -1. Okay, so there's a lot going on here, and we need to make sure we follow the order of operations. So the order of operations tells me in which order I should solve things. So the order of operations, if you remember, is PEMDAS. Parentheses, exponents, multiplication and division from left to right, and then addition and subtraction. So the first thing I'm actually going to solve here, well, what I can do first is, this is technically multiplication. Negative, that's really like -1 times -5. This would turn into +5. Okay, so +5 plus 9 times -2 minus -1. So now I'm going to underline what I should do next. And let's see, I have addition, multiplication, and subtraction. Multiplication is first. So I'm going to work on 9 times -2, which would be -18. So I still have 5 plus, I got -18, minus -1. Now I have addition and subtraction, which I can solve from left to right. So the next thing I'm going to do is 5 plus -18. 5 plus -18 is -13 minus -1. Now I'm going to use keep, change. So -13 minus -1 becomes -13 plus +1. And -13 plus +1 is -12. Okay, so my work makes this upside down triangle that kind of looks like a Christmas tree, upside down. Okay, so hold on. So I draw my Christmas tree, and I'm going to highlight the answer that's like my star at the top of the tree. So yes, this is an upside down Christmas tree, but it looks like a Christmas tree. We're going to solve one more problem that you're going to come across. So here's another example. This one is x times y minus z, minus 2, all divided by 3 times y. All right?
This is Leah. Please call the office.
Okay. So what we're going to do is replace each variable with the number it belongs with. However, I'm going to separate the numerator of this. This is like its own problem at the top, and the denominator is its own problem. And the fraction bar is the division. So I'm actually going to rewrite this as xy minus 2 divided by 3y. So that's how you should rewrite a problem that looks like this. Okay, now I'm going to replace each variable with its correct number. -7 times -2 minus 2 divided by 3 times -2. Now what I'm going to do is use brackets here because I had parentheses inside already, and these can go in their own brackets as well. Looks complicated, but it's really not. So all I did here was make sure that my negative numbers were in parentheses to separate them from any other operation, and then instead of parentheses on the outer edges of my problem, I used brackets. Now I'm going to solve. So I'm going to start with what's on the left first, and I'm going to solve negative 7 times negative 2. That's positive 14, and I still have that minus 2, okay, divided by 3 times negative 2. Next up would be 14 minus 2. 14 minus 2 is 12. I don't need the brackets anymore because I have my answer. 12 divided by, and then we have 3 times negative 2. I can keep the brackets. The next thing that I would want to solve is 3 times negative 2, okay, because that's in parentheses or in the brackets, which are like parentheses. So I'm going to have 12 divided by negative 6. 3 times negative 2 is negative 6. And finally, my answer would be negative 2. All right, so I'm going to draw my Christmas tree. Highlight my answer. And I'll leave this here for a second. If you want to screenshot this, this would be considered a more complex expression to evaluate because you have something in the numerator and something in the denominator. It looks more complicated than it is, okay? So the brackets, remember, are like parentheses. And you just have to go one step at a time. So you can see where I've underlined which step I'm working on at each level of the problem. I recommend that you do that. Your work should look like this. Notice how there's no equal signs. I'm not writing an equal sign. I'm evaluating the expression from top to bottom. Okay, on today's classwork, you should solve your problems just like this, and they're going to make upside down Christmas trees.